Hey everybody, welcome back to Mr. A's geometry course. Today we're going to be starting section 3.5, which is going to be split into 3 videos. The first one here is about partitioning directed line segments. Let's get into it. A directed line segment is a segment that represents movement from one point to another. So we know in a typical segment there are endpoints. And we don't really think of the endpoints or either endpoint as a start of the segment or the end of a segment. Those are just the boundaries for the segment. But on a directed line segment, we do need to think of a point as a starting point and another point as the end point. For example, in a directed line segment AB, if I'm calling it a directed segment AB, we want to think of it as starting at A and then moving to finish at point B. Right? For a directed line segment CD, we want to think of that as starting at a point C and moving to end at a point D. So directed line segments give us movement, show us direction, and that's extremely important for today's lesson. What we're going to be doing to these directed line segments is we're going to be partitioning them, which means to split or divide into smaller pieces. Right, so these smaller pieces that we get on our segments, we're going to be creating ratios with them. And as a reminder, a ratio is just a comparison of values, just a comparing numbers to each other. So as we look at this segment shown here, we can see points B and A. If we think of this as a directed line segment BA, so going from B to finish at A, we have at point P, and we have several other points here that are splitting this segment or partitioning it into smaller pieces. And we see that before point P, there's only one piece, only one part there. And then after point P, we have 1, 2, 3 parts from point P to point A. So there's a ratio now that we have, a comparison of segment BP to segment PA and how many parts are on those segments. As we mentioned, there's 1 part from B to P compared to the 3 parts from P to A. So check the wording here. We can say point P has partitioned directed segment BA into a ratio of 1 to 3. 1 part before point P, 3 parts after point P. The focus of our lesson today is going to involve segments on the coordinate plane. We're going to be partitioning them and finding points that partition them into specific ratios. So we can do this, we can solve for those locations by using the slope of the segment, right? The slope really is technically how far away our points are. It's rise over run. It tells us how far up or down our points are from each other and how far left and right our points are from each other. So we can use that slope along with a given ratio for how the segment's been partitioned to find these points that split them into these specific ratios. In our first example here, we're asked to find the coordinates of point P on directed line segment AB. Before I do anything else, I just want to make sure that the picture is painted here. So we don't have a graph. We don't really need a graph to do this. I'm not going to draw one to show you, although there are some ways we can learn how to partition that involve actually graphing these points. I just want to make sure you understand the visuals here. Somewhere on a graph exists a segment AB, and we are moving, because it's a directed line segment, we're moving from A to B, and we're finding some point along the way that splits it into a ratio of 3 to 2, meaning 3 parts before point P, and since our direction is going from A to B, that means 3 parts from A to P, and then 2 parts after point P on the way to B. All right, so 3 parts before, 2 parts after, and just like points A and B have coordinate locations here, we're going to be able to find the coordinate location for point P. So the first thing that we're going to do is we're going to figure out how far apart are these points, these endpoints on our segment. Now don't get that confused with the distance, right? We're not using the distance formula here. Instead, we're going to use the slope formula. We're going to see how far apart our x coordinates are and how far apart our y coordinates are with our slope formula. So I'm going to give you a little process here. The first thing that we're doing is we're going to find the slope of our directed line segment. All right, so we have segment AB, and I'm just rewriting my points so that I can label them. It's extremely important. So we got A at 3, 2. We have B at 6/8. And just like we would label for the distance formula or the slope formula, we're going to label our points. Very important though, this is a directed line segment, meaning we have to start at point A. That needs to be our ones when we label. So this is x1, y1. Point B will be our x2 and our y2. And we're gonna plug these into the slope formula. The slope formula is provided on the reference sheets in the state of Florida, so you don't have to have this memorized, but for the sake of this example, this is our slope formula. y2 minus y1 over x2 minus x1. It's gonna give our rise and our run. The y's are our rise, the x's are our run. It'll tell us how far apart these coordinates are from each other. So y2 minus y1, well my y2 is 8, minus my y1, which is 2. x2 minus x1 on the bottom here, my x2 is 6, minus my x1, which is 3. And I'm subtracting now. 8 minus 2 gives me 6, 6 minus 3 gives me 3. I'm not going to simplify this. I know 6 over 3 is actually 2. We're not like solving for the slope of a line or anything right now. We're leaving this, not simplifying it. 6 over 3. So again, this tells us how far apart our points are on the segment. The y coordinates are 6 units apart. The x coordinates are 3 units apart. The point that we're trying to find is going to be splitting these distances into a ratio of 3:2. Okay? So we have to know now what that ratio means in terms of the distance from A to B. And so the second thing that we're going to be doing now is we're going to be finding a fraction. Finding a fraction. That all comes from that given ratio, right? So the ratio that was provided to us was 3:2. And I want to show you very quickly what I showed you previously with this segment up here and how the ratio works with the amount of parts that are on our segment. Point P split this segment in a ratio of 1:3. You'll notice on the segment itself though, there are 4 total parts. So another way to say this, and the way that's going to be useful for us in our problems here, is that point P is 1 out of 4 parts the distance from B to A. We could also say it's 1/4 of the distance from B to A. So 4 total pieces involved there in that ratio. Let's see how that works in our example. With a ratio of 3:2, 3 parts before, 2 parts after, that's a total of 5 parts. Right? We get that from adding these values together. 5 parts total. Our point has 3 parts before our point is located, right? Before the location of our point. So turning this into a fraction is using that 3, the amount of parts before our partitioning point, out of the total amount of parts on our segment, which is 5. So a ratio of 3:2 means our point is 3/5 of these distances from A to B. All right? The next thing we are going to do now is find out what is that fraction of this distance. What is 3/5 of 6? What is 3/5 of 3? All right? So step 3, we are going to multiply the slope by our fraction. So we had a slope of 6/3, 6 over 3. And we're going to multiply both the numerator and the denominator by this fraction that we came up with from our ratio, by 3/5. By 3/5. As a reminder, when you multiply by fractions, you're going to multiply by the numerator and then divide by the denominator. So I'm going to do 6 times 3 and then divide that by 5. So 6 times 3 is 18. 18 divided by 5 gives me 3.6. So my resulting value up here is 3.6. And on the bottom, I'm going to do 3 times 3 divided by 5. 3 times 3 divided by 5 gives me 1.8. Now, this is a very crucial moment with the numbers that we got here and understanding what these numbers mean. Remember, our slope formula has y's up top. It has x's on the bottom. So remember, this here means that we're 6 units apart for our y coordinates. We're 3 units apart for our x coordinates. That's from A all the way to B. Now we've just found out the distance we are away from our partitioning point. So it's 6 units all the way across, but it's going to be 3.6 units to get from A to our partitioning point. Remember though, on top was our y coordinates. So it's very important to note right here that this came from the y's. And then we learned here that we're going to be 1.8 units away from our x coordinate, because again, on the slope formula, we have x's on the bottom. So this is from our x's. And the last thing we're going to do now is we're going to take these values and we're going to add them to the starting point of our segment. So remember, we talked about directed line segments representing movement. If we started at A and ended at B, that means our partitioning point is going to be this far away from point A, from the start of our segment. So reminder, A here was at +3, +2. I'm going to take that x number and add it to the x coordinate here. So the x coordinate was 3, I'm adding 1.8 to that x coordinate. My change in y now needs to be 3.6, I'm adding that to the y coordinate there. The 2, I'm adding the 3.6 there. And the resulting values will be my location for my partitioning point. So I started at 3, we found out that our point needed to be 3/5 of the distance of our slope from A to B, and we determined that's going to be 1.8 units away from point A, so 3 plus 1.8 gives me an x coordinate of 4.8. I'm doing the same thing with our y's. We needed to be 3.6 units away from our start, which was at +2. So +2 plus 3.6 will give me 5.6. And that will be the location of my partitioning point, 4.8 for my x coordinate, 5.6 for my y coordinate. Guys, partitioning, as you can see, it's a process. It takes a while. We got to practice and really get the process down here. We're going to do the slope between our points. We're going to figure out from our ratio what fraction of the distance our point is from start to finish. We're going to multiply the slope by that fraction, and then we're going to add our resulting values to our starting points to find our partitioning point. Lots of work, but with enough practice, we're going to be able to get this down. So we're going to be continuing our practice here, doing that same process to find the location of a partitioning point. We have a segment LM. Point L is located at -3, +2. We have a graph here on this one, so I will graph these points to give you a visual. That's point L. Point M is located at +5, -4. So let's write 5 down 4, that'll be right there. That's going to be our point M. You can connect those here. That is segment LM. Notice it says we're going to find a location of point S that partitions the directed segment LM. So that gives us direction. We're starting at L and ending at M. And we're going to partition it into a ratio of 2:6. So there's going to be a point S somewhere where that gives us 2 parts before it and 6 parts after it. Sorry, that's awful handwriting. Let me redo this. So they're going to put a point S somewhere that's going to give us 2 parts before it, 6 parts after it. Okay, and I just roughly put where that point S is located. There is a way we can find this out on the graph, but again, I'm going to be showing you that same process I showed you before, how we can do this with our coordinate points and our slope formula. So the first thing we're doing, like our previous example, is finding the slope between our locations. So segment LM, we have point L located at -3, +2. We have point M located at +5, -4. And remember, labeling your points allows you to avoid silly mistakes when we plug these into our slope formula, right? So don't get this M confused with point M, right? M is just the letter that we use for slope, for our slope formula. We have y2 minus y1 for slope on our numerator, so that's -4 minus 2. And then x2 minus x1 for our denominator, so 5 minus -3. The results of these, -4 minus 2 would be -6, and then 5 minus -3 would be +8. And remember, we are not going to simplify this. We are going to leave it as that fraction. Our next thing, remember, is to turn our given ratio into a fraction. 2 parts before, 6 parts after. Remember, that is 8 total parts. So a ratio given to us was 2:6. We know 2 plus 6 is 8. So we have 2 parts before our point out of 8 parts in total. Our point is going to be 2/8 of the distance from L to N. Remember what we did at this stage. We took that slope and we multiplied by this fraction. If it's -6 units apart for our y coordinates, we need 2/8 of that to find our partitioning point, which is called point S in this example. It's 8 units apart for our x coordinates. We need to find 2/8 of that distance to get to our point S. And we're multiplying from here. So we're doing -6 times 2 divided by 8, right? -6 times 2 is -12 divided by 8 would give us -1.5, okay? 8 times 2 is 16 divided by 8. This would give us a 2 on the bottom. We do 8 times 2 divided by 8. Remember, the top value comes from your y coordinates. We do y's up top in the slope formula. The bottom value is for your x coordinates. These numbers now represent how far away our point S is from the start of the segment. So as a reminder, this segment was called LM, which means L is the start of it on the directed segment. So we had an x coordinate of -3, y coordinate of +2 at our starting point. We determined here our x coordinate is going to be 2 units away from point L. So I'm adding that 2 from point L. Our y coordinate is going to be -1.5 units away. So since this is negative, I am subtracting that value from my starting point, my y coordinate. And that'll lead us to point S. So we have -3 plus 2 to give us an x coordinate of -1. And then we have 2 minus 1.5 to give us a y coordinate of 0.5 for our partitioning point. I hope you're starting to get the hang of this now. I'd like for you to now pause the video and see if you can do this next example on your own. Again, at this stage, I don't expect mastery. Feel free to look back at your notes and your step-by-step process, but see if you can get this on your own without hearing me go through it first. All right, let's see how you did. I'm gonna work through this a little bit quicker than our previous examples. Now remember, the first thing I'm gonna do is find my slope. My points are listed here in a nice easy place for me to label them, so I'm gonna label where they are. There's x1, y1, x2, y2, and I know my slope's gonna be y2, -27 minus y1, which is 9, over x2, which is 13, minus x1, which is -5. We do -27 minus 9, we're going to get -36. When we do 13 minus -5, we're going to get +18. We're given a ratio of 2 to 7, and I know that in that ratio, I'm going to have 9 total parts. My point will have 2 parts before it, 7 after, out of the 9 total. So it's going to be 2/9 of the distance from A to C. So I'm taking now my slope, and I'm multiplying those values by my fraction. Both of these getting multiplied by 2/9. So when I do -36 times 2 and then divide it by 9, I would get -8 as a result there. When I do 18 times 2 and divide it by 9, I would get +4 as a result there. Remember, these are now the distances away that our partitioning point is. So our partitioning point is going to be point B, and we started at point A at -5, +9. So we started at -5, +9. We found out that our y is going to be -8 units away. Our x is going to be 4 units away. So we're adding that 4 to our x coordinate. We're subtracting that 8 from our y coordinate. Our point B would then be -5 plus 4 is -1. 9 minus 8 is +1. Our partitioning point would be at -1, +1. Last example of our notes here. There is very minor difference in the way this question is worded, but that minor difference makes a huge difference in the result to our answer. Take a moment to see if you can spot what that difference is. Hopefully you noticed that we weren't presented with a ratio in the typical way of our last few examples. This didn't say that our partitioning point is creating a ratio of 3 to 4. Instead, this says that we're going to find a point that is 3/4 along the way from L to M. So what we need to understand is that our fraction is already given to us. Fraction is already provided. Fraction is already provided. Very, very, very important. So we're not changing this. We're not saying 3 parts and 4 parts, 7 total parts. This is 3/4 of the distance. This is the result of our ratio, right? Just to give you a little visual recognition of this, what we're saying here is 4 total parts. Our point is here with 1, 2, 3 parts before it, 1 part after it. It's 3 out of 4 parts from start to finish, okay? Once we understand that everything in the process is still the same, we've just already got our fraction. We're not gonna be doing this part over here where we take our ratio and turn it into our fraction because we already have that part, okay? I know I just said the same thing a lot of times. It's just important, right? 3/4 is the fraction that we're gonna use here. So slope formula to start, right? We have, let me rewrite these here so that I can label them clearly. We have L at 0, -3. We have M at -12, +21. I got x1, y1 because that's the first point on my directed segment. We got x2, y2 here, and we're plugging into our slope formula. So y2 minus y1, be 21 minus -3, x2, -12 minus x1, which is 0. 21 minus -3 is +24, -12 minus 0 is -12. Remember, we already have the fraction here. It's 3/4. So I'm taking my slope, I'm multiplying both the numerator and denominator by that fraction of 3/4. 24 times 3 divided by 4 give me +18. -12 times 3 divided by 4 give me -9. Remember, this came from my y's, this came from my x's in the slope formula, so I'm adding this now to my starting point. We started at L at 0, -3. So my x is -9 units away, so I'm subtracting 9 from the x coordinate. My y is +18 units away, so I'm adding 18 to my y coordinate. That'll get me to my partitioning point. 0 minus 9 is -9. -3 plus 18 is +15. That's our partitioning point in this example. Again, the key is recognize when you're just being given a ratio versus when you're being given that fraction of the distance already. And so that would be saying in the question, it would say something like your point is 5/7 the distance from start to finish. That's when you get the fraction already provided for you and you don't have to change the ratio. Guys, that wraps up our lesson on segment partitioning. You need practice now. We got to do lots of examples to get really good at this, okay? So if you're one of my students, you have plenty of practice examples in your packet. If you're someone that just came across this video, there are tons of resources that you can just Google search to find some practice with partitioning segments. Again, that's all for today. We'll see you in the next video for lesson 3.5. Bye, guys.